Seminario, però io adesso parlo in italiano perché penso che la maggioranza mi scuso con gli ospiti stranieri, ma la maggioranza magari preferisce l'italiano, quindi io farò l'introduzione in italiano, poi dopo le relazioni si potranno fare penso in inglese perché tutti parlano molto bene l'inglese. Questo seminario nasce da un'iniziativa che abbiamo avuto con l'azienda Technogenetics e con l'azienda IBSA di cui Technogenetics fa parte, anche allo scopo di far conoscere meglio dal nostro punto di vista il centro di fecondazione che noi abbiamo inaugurato a gennaio. Un centro noi notoriamente ci occupiamo di endometriosi, un centro di fecondazione che avrà una sua componente dedicata alla endometriosi. L'endometriosi per noi è una specie di modello ideale per studiare i problemi della infertilità, in quanto questi pazienti, è noto, sono noti anche come un po' la bestia nera dell'IVF. Sono pazienti che a vario livello possono presentare dei problemi specifici che interferiscono con la procreazione e quindi costituiscono un modello di studio ideale per poter approfondire sia gli aspetti ovarici a livello degli ovociti, a livello della funzione delle salpingi e poi anche a livello dell'endometrio, cosa che noi già stiamo facendo come Fondazione Italiana Endometriosi nel campo, diciamo, della ricerca. Siamo onorati di avere due dei più grandi esperti al mondo sulle loro tematiche, i terreni di coltura e il dottor Conagan per la vitrificazione, uno dei pionieri della vitrificazione, e quindi noi pensiamo che questo enhancement di tecnologie nella fecondazione assistita sia estremamente importante dal nostro punto di vista, in quanto ci può risolvere quello svariato numero di problemi che i pazienti con endometriosi presentano. Quindi tutto ciò che è innovazione tecnologica in questo settore viene amplificato quando abbiamo di fronte un problema, diciamo, più difficile, come può essere la paziente con endometriosi. Sappiamo che in Europa ci sono circa 15 milioni di donne affette dalla malattia, il 40% di esse ha problemi di infertilità, quindi stiamo parlando di una quantità enorme di soggetti che devono accedere o dovranno accedere alle tecniche di fecondazione assistita. Quindi ci piace questa sfida e accogliamo con entusiasmo anche le relazioni che verranno e di cui noi daremo un piccolo contributo come fondazione su questo studio che è uscito su Frontiers in Bioscience in gennaio 2012 sul modello animale, il danno congenito dell'animale al quale è stata indotta l'endometriosi, danno congenito ovarico. Quindi chiamo il professor Tucker alla sua prima presentazione. Professor Tucker, prego.
Good afternoon, everyone, and thank you for the opportunity for me to present today. And I will attempt to get done in about 30 minutes. And it's my pleasure today to present a fairly simple story. But first, let me just explain a little bit about the clinic that I work with in just outside of Washington, D.C. in the United States, in Rockville. Group it's called Shady Grove Fertility, and I've worked with them now as laboratory director for 13 years. And it's a very special place for me because I have traditionally enjoyed working in small IVF programs of a few hundred cycles, cases a year. But Shady Grove has grown since I started from some 900 cases a year to now, last year we did over 4,500 egg retrievals. So it presents a very interesting challenge to be able to cope with the scale of that operation. And so the focus of this area of my talk is one small attempt of many to try to streamline and make the IVF process simpler, faster, and less open to risk or problems. So I will be talking about a true single-step culture medium, and that is, for any biologists, embryologists in the audience, you understand that our lifeblood in the IVF lab is the culture medium and the quality of it, the culture medium in which the embryos grow. And I will discuss where we are in the state of that art and how we, in our own small way, have now moved to using just one single medium from the time of egg retrieval all the way through to embryo transfer or cryopreservation. I'll just talk in general about embryo culture protocols. Irvine Scientific were very helpful to myself and the clinic to develop this single-step medium, taking their initial single-step medium, which has been on the market for several years now. We had the opportunity over the last 2-3 years to develop that to a level for ourselves where we are able now to feel very comfortable with its performance, and it will be a new medium as introduced here, embryo choice. We'll discuss the initial trials that we ran at the end of last year in the human, so initial mouse studies, then human embryo trials, and then general use, since we've gone live with this use of this medium for the last several months. Just make some comments on that. I will also just talk in a little more general terms about how we incubate the embryos. So we'll actually talk about the mechanics in the lab, the incubators themselves. But if we look at human IVF protocols, there are two general philosophies in how embryos are grown in the lab. These two philosophies could be referred to as back to nature principle, and this is where several different culture media are used to mimic what occurs in the female reproductive tract, whether it's high up in the oviducts, the fallopian tube, or whether during its passage down through that tube and into the uterus. The theory goes that the composition of the environment the embryo finds itself in changes, and therefore in culture, as the embryo grows from one cell out to the blastocyst stage, we need to present it different types of medium because the embryo needs different nutrients along the way. The second and less common approach or philosophy is what we like to refer to as let the embryo choose approach. That is, present one medium but with the right concentrations of constituents, the ingredients, the nutrients in that culture medium. The embryo can eat or take in just what it needs. So in colloquial way we refer to this as the buffet, or as we were in Barcelona giving a talk, I was a couple of days ago, tapas may be an appropriate terminology. But basically the embryo has access to all its necessary nutrients throughout its exposure to this one medium. In the first, more common approach to culture medium use is the use of sequential media protocol, with a different culture medium here for the early stages for cleavage, and then here at the cleavage stage breaking into a fresh culture medium for blastocyst growth. And if you consider the medium into which the egg is collected and inseminated to make this embryo the day before, there is a third culture medium. So you need 3 media to put this whole approach together. And this is probably throughout the world has been a more common approach. The let the embryo choose single medium approach has been around. It was introduced in the early 2000s by John Biggers, who decided that as we work in an artificial environment in vitro, why try to attempt to mimic that which happens in vivo in the body? Why not just accept it's an artificial environment and come up with an optimized, improved single medium? Now there has been on the market for a number of years now one notable single-step medium, which is Life Global. However, even that, most people renew. They change the medium into fresh medium on the third or fourth day of development, even though it's the same medium. So it's an extra step that's utilized. Plus, in most cases, people using Life Global do not use that medium to inseminate the eggs in. So they actually still use two different media. What we were seeking for labor and just reasons of simplification of IVF was the potential to develop a true single-step medium without any renewal here halfway through culture, going all the way up to 5-6 days of culture to the blastocyst stage, continuous. But let's just dwell for a little moment longer on why are sequential media considered, or have been over the last decade or so, why is the sequential approach so attractive? Well, the back to nature principle does seem a very comfortable thing to adopt. The other thing is that the assumption that changing culture medium will enable you to move the embryo out of medium which may have metabolic waste products build up, or just from the breakdown of amino acids you end up with embryotoxic ammonium in the culture medium, or indeed for extended culture, perhaps regardless of the culture medium, build up of volatile organic compounds absorbed into the culture medium may make that medium more less appropriate for the embryos to be in. So the idea of changing medium seems a reasonable thing if you accept these are issues. The movement of the embryos themselves may be using a pipette, moving into fresh medium mimics the movement that an embryo would experience